Modified Gaussian integral xi. So this is the 11th video on the series of modified Gaussian integral. So basically before this I have already solved different other problems like integral from 0 to infinity of e to the power minus lambda w of x whole square dx. Also integral from 0 to infinity of e to the power minus ln square x dx. Yeah, and also like some other problems like integral from 0 to pi by 2 of e to the power minus sine square x dx, or like some other problems like integral from 0 to 1 of e to the power minus sine inverse x square dx. So I've already tried such problems. Yeah, and you can check those problems over here in the playlist. I'll also keep the playlist in description. And for now, let's look at this a beautiful girlfriend of Gaussian integral, because it replicates the pi by 2, but it gets slightly complicated by e to the power 1 by 4. And yeah, complicated stuffs are always calls. Okay, fine. So we can also like say this as a crazy integral. But yeah, now let's look at how do we solve these problems. Yeah. So of course you might say that the first thing we want to do is to make a u substitution. That is y equals to arc sin h of x. Yeah. And for now, let us just solve the indefinite integral for now, and later on we will substitute the limits. Yeah. Integral of e to the power minus y square, and we know that sin h of y is equals to x. That's why dx equals to cos h of y dy. Yeah, and so dx equals to cos h y dy. Now after this we can do the definition of cos h y. Yeah, e to the power minus y square, cos y is e to the power t plus e to the power minus t by 2. But since here's y, I should have written y over here. I'm sorry. Baby I okay. So 1 by 2 integral of e to the power minus y square plus y plus e to the power minus y square minus y dy. Okay, now let us try to complete these squares. Yeah, e to the power minus of y square minus y, and to complete the square we need to have plus 1 by 4 and similarly a minus 1 by 4. Over here also plus e to the power minus of y square plus y plus 1 by 4 and minus 1 by 4, and then dy. Yeah, now after this we will have minus minus only plus, so let's take e to the power 1 by 4 outside by taking common from both of the terms, and this is e to the power minus of y minus 1 by 2 whole square plus e to the power minus of y plus 1 by 2 whole square dy. Yeah, and now we know that this integral is just the orf function. So e to the power 1 by 4 by 2, this is orf of y minus 1 by 2 plus orf of wait a second, also with orf I need to write root pi by 2 as well, so that's why I will just write over here, okay, root pi by 2, taking common from both of them, root pi by 2. Yeah, now our y was arc sin h x. Yeah, that's why this will be root pi by 2 e to the power 1 by 4 by 2 orf of arc sin h x minus 1 by 2 plus orf of arc sin h x plus 1 by 2. Okay, Now we need to evaluate this in between the limits of 0 to infinity. Yeah. And now you might recall the logarithmic definition of arc sin h x. Basically, sin h inverse x, this is ln of x plus root under of x square plus 1. Yeah. So from this logarithmic definition, we can find both the sin h inverse 0 and sin h infinity. At 0, this is ln of 1, so that's 0. At infinity, this is ln of infinity, so that's infinity. So now, since we know these values, we can evaluate this, and this will come out to be root pi by 2 e to the power 1 by 4 by 2, and orf of infinity is just 1, orf of infinity is just 1, minus, and then this is orf of minus 1 by 2, and minus this is orf of 1 by 2. Yeah. Now we know that 1 minus orf function is orf c function, that is complementary error function. That's why root pi e to the power 1 by 4 by 4, 1 minus orf minus 1 by 2 is orf c of minus 1 by 2, and 1 minus orf 1 by 2 is again orf c of 1 by 2. Now we know that because this is because orf c of x is 1 minus orf of x. Yeah. Okay, the next property that we will use is orf c of minus a plus orf c of plus a, that's equal to 2. You can try proving this on your own from the definition of these functions. Yeah, it's not that hard. And this is equal to 2, so that's why this sum will also be equal to 2. That gives us root pi by 4 e to the power 1 by 4 into 2. So now this simplifies to root pi by 2 e to the power 1 by 4, and that is the answer. So we solved this problem. To talk about the flow of the problem, we first made use of substitution, use the definition of hyperbolic cosine, commutative square, use definition of orf, use properties of orf c, and yeah, we solved the problem. And we also use definition of sin h inverse x. So that was it. It took around 8 minutes 40 seconds. And yeah, hope you enjoyed the problem and the solution. And thanks for watching. Do share with the friends too, and do check other videos too. Look forward to seeing you in the upcoming videos.